All right, recording now, so nobody say any bad words. Last week when we met, we were talking about factoring. And we talked about the greatest common factor, and then we edged into factoring trinomials. And those that did the factoring trinomial ed puzzle, you kind of know where we're going to be going with this. And today is just a very tiny expansion on it. But since I know most of you did not do the factoring trinomials ed puzzle yet, I'm just going to give you a little brief overview of it. Because you kind of need to know it to do the part we were doing. When we talked the other day, we were just looking for the factors, and today we're going to be converting those into solutions. And I gave you a chart that said when we're factoring trinomials, and we were being very specific. We were talking about trinomials of ax squared plus bx plus c, where a is equal to 1. And so what would that look like? It would look like x squared plus bx plus c, right? And I gave you a little chart that broke down what those factors would look like. So if I had x squared plus bx plus c, the factors would come out to be x plus something, x plus something else. If I had x squared minus bx plus c, my factors would come out to look like x minus something, x minus something else. If I had x squared plus bx, oops, sorry. This is about to be minus c. Minus c, our factors would come out to be x plus something times x minus something. And those somethings, which one would go in the plus and which one would go in the minus, depends on our b. If our b is plus, then our x plus something is here, our bigger factor goes here, and our smaller factor goes here. If our b is negative, we still have x plus something, x minus something. Oops. But our smaller factor, our bigger factor would be negative instead of the smaller factor. And I can show you what that looks like down the road. It just means if I have the numbers 6 and 2, the bigger one, the 6, is going to be negative if this is negative. And in this case, the 6 would be positive if the b is positive. And so in terms of that, say I had an expression like trying to find the one I used in my other class earlier, but I cannot find where I put that. If I had, say, x squared minus 15x plus 26, and I wanted to find the factors of that, I'm going to take my factors of c. Oops, sorry. I'm going to find the factors of my c value, find factors of c that add to b, right? And if I look at this, my a is 1, which is why I have no number there. My b is negative 15, right? And my c is 26, right? This is my b, this is my c. So I'm going to find all the factors of 26 that add up to 15. So the first thing I'm going to do is if I don't know it right off the bat, I'm going to list my factors of 26, right? I'm going to rewrite this over here. X squared minus 15x plus 26. So my factors of C are going to be whatever the factors of 26 are. So 1 times 26, 2 times 13. And I know that those are all of the factors I have of 26. 3 doesn't go in, 4 doesn't go in, 5 doesn't go in, right? What do I know about these factors? I know I have a minus here and a plus here. Well, look, I have a minus here and a plus here. So both of my factors are going to be x minus something, right? And my minus something is going to be 2 and 13 because 2 and 13 equal 15. And that's what we do when we're looking for factors. And hopefully you'll watch through the Edpuzzle explaining all of that, because that was our lesson from earlier this week. So please do that Edpuzzle and the assignment attached to it before you do today's homework, right? It'll help you so much. What today we're expanding on is we're doing the same thing, but we're finding the solutions. So if we have this same problem, right? X squared minus 15x plus 26, and we set it equal to 0. We can set it equal to anything, but right now we're going to set it equal to 0. When we are looking for the solutions to a quadratic equation, we are looking for the zeros. We are looking for what is x when the whole thing is set equal to 0. So our factors aren't going to change, right? Our factors of this are still going to be x minus 2 times x minus 13, right? But those are going to be set equal to 0. Because x squared minus 15x plus 26 is the same as saying the quantity x minus 2 times the quantity x minus 13. If I distribute those out, if I multiplied these two things together, I would get this equation, because that's what a factor is, right? In the same respect that if I multiplied 2 times 3, it would be 6, right? 6 and 2 times 3 don't have different values. They may appear differently, but they're both equal to 6, right? So the factors of something don't change the value, right? This is still equal, if I multiplied it through, to x squared minus 15x plus 26. And the way we solve these is we figure out what the zeros are. And the way we do that is by using what we call the zero product property. And you guys might not know the term zero product property, but you know what it is. You've known it for a long time, right? You just didn't know that it was called the zero product property. And the zero product property says that when I multiply something times 0, I don't need multiplying anything by 0 gives me what? Right. You guys have known this for a really long time, right? If I have 1,000,000 multiplied by 0, I still have 0. If I have 2 multiplied by 0, it still gives me 0. So if you look at the expressions that we have here, we're saying that this times this equals 0. So if I can make either of these equal to 0, the whole thing is 0. And that's a true statement, right? Because we're saying that it equals 0. So what we're trying to look at is, how do we create zeros in these? How do I make x minus 2 equal to 0? Well, I just said it as x minus 2 equals 0. Because if this whole thing equals 0, and I multiply it times this whole thing, I'm still going to get 0. But also, if I make this whole thing equal to 0, right? If this equals 0 and I multiply it times this, doesn't matter what this is, we're still going to get 0. So our solutions are finding these things equal to 0, right? And solving for x. So here, I have x minus 2 equals 0. So if I add 2 to both of these, I get x equals 2. It's saying if I plug in 2 for x right here, this whole thing becomes 0, right? And is that true? If I plug in 2 here, I get 2 minus 2. This whole thing is 0. When I multiply it times this, the whole expression becomes 0. Also, if I figure out what x is here, right, I'm going to get x equals 13. Well, if I plug in 13 here for x, right, 13 minus 13 equals 0. And so when I multiply it times x minus 2, no matter what x minus 2 is, I still get 0. And these are what we consider the solutions of quadratics, right? We find the factors, we set them equal to 0, right? And then we find our solutions. We solve for x or whatever the variable is, and then we have our solutions. So let's look at if I had, let's go n squared minus n minus 72, right? What do I know equals 0? Sorry. I know that I am going to have n plus something and n minus something by my chart, right? I can't have a negative c term and not have a positive and a negative factor. So I'm going to take my factors of 72 that add up to -1. And I talked to you before when we looked at this chart. I said our bigger factor, if this is positive, our bigger factor is positive. If this is negative, our smaller factor, I mean, our bigger factor is negative, right? The bigger factor is whatever this sign is, our B. So whatever our bigger factor is going to be on the negative side. So when I look at my factors of 72, I will have 1 and -72. I will have 2 and I don't know how many, -36. 3 will go in. I'm not sure what 3 equals. -224. I don't know if 4 goes in, but I can tell you right now that 8 times -9 will give me -72, right? My bigger factors are always going to be the negative in this one because this is negative. I'm going to look at these factors. I'm going to add them together. 1 plus -72 is -71. 2 plus -36 is -34. But 8 plus -9, right, gives me -1, and that's what we want. So we know that this factor is 9 and this factor is 8. And once I get to this point, I can set each factor, n plus 8 equal to 0 and n minus 9 equal to 0, to find my solutions. right? So we're only taking this one step further than we had it the other day. So on this side, I'm going to subtract 8, right? Because I have to do the opposite of what's being done to it. And I get n equals negative 8. Here I'm going to add 9 to both sides, because again, we're doing the opposite. And I'm going to get n equals 9. These are my solutions right here that would make the equation equal to 0. And we look at in terms of graphs, it will be those points where when we graph it, the parabola that our quadratics come, that's where they're going to cross the x-axis. But you don't really need to know that just yet. I'm going to do one more example, because the other day when we talked about factoring out greatest common factors. I'm standing to teach today. It's really weird. I haven't done that in a while. And it meant that we had said that before we start any problem, we have to see if we can factor out a greatest common factor first. So if I have 5x squared minus 25x plus 30, the first thing I want to do, equals 0. So we're looking for solutions. The first thing I want to do when I'm looking at that is go, can I factor out anything? Because we have only been dealing so far where a is equal to 1. And so I'm going to factor 5 out of all of this so we can keep with that term, right? Because everything here is divisible by 5. This divisible by 5 just gives me x squared. Minus 25 divided by 5 is minus 5x. 30 divided by 5 is just plus 6. We set that equal to 0. So when we do this now, we just need to find our factors that work. We know that they're going to be x minus something times x minus something else. And we know that because of our chart, right? I have a minus plus, and if I come back up here to our chart, I have a minus plus, and that gives me 2 x minus factors, right? So now I need to look at, I'm not factoring this big thing. This is my new a, b, and c right here. I have a 1, a negative 5, and a 6, right? 1 is my a, negative 5 is my b, 6 is my c. So we are going to take the factors of 6, find the factors of 6, that equal negative 5. What do we know about them? They're both going to be negative, right? So 6, if I want them both negative, I'm going to have negative 1 times negative 6, and I'm going to have negative 2 times negative 3. This is a small number, so we don't have any more factors. The ones that add up to, these add up to negative 7, these add up to negative 5. So these are the ones that we're going to use. So here I'm going to put in 2, and here I'm going to put in 3. And so when I go to solve them, again, I don't have to worry about the 5, because if I make either of these a 0, the whole thing's still going to be 0, because when I multiply 5 times that 0, we still get 0 for a solution. So to find our solutions, we're just going to take these factored quantities, our x minus 2, and set that equal to 0, and our x minus 3, and set that equal to 0. And whatever solutions we get here, oops, sorry, I don't know what I'm doing anymore. So we're just going to solve for x. We're going to isolate our x. So I'm going to add 2 to both sides. We get x equals 2. And add 3 to both sides. And get x equals 3. These are our 2 solutions. Sometimes you'll only have one solution, but we will get into that with special products, probably in your Edpuzzle for next week. This is all I have for you in terms of the lesson. I'm going to have you guys do a problem on your own into the chat box, but I'm going to stop the recording now. because we don't need to see that part on in the